Uh, just to know how to apply Venn diagrams in solving questions in probability, we will discuss the basic concept of Venn diagram. A Venn diagram is a diagram of sets showing two or more sets and classifying various members of sets according to their attributes. So we sort data according to the given two criteria or given two sets. Um, let's consider an example of 10 students. So we have 10 students here and we will sort them according to their hair color, brown color, whether a student has brown color or not, and whether he or she wears glasses. So there are two criteria. Number one, whether the student has brown hair, and the other criteria is whether he or she is wearing glasses or not. So first we will make a universal set. A universal set is the largest set which contains all the small sets, and then we are making a set of brown hair students. All the students who have brown hair will come inside the set, in the set, inside this set. And secondly, we have another set labeled glasses. All the students who wear glasses will come inside this set. And the students who have brown hair and glasses, they will come in both of the sets, and they will come in the overlapping part of the sets, which is in the middle. You can see where the two sets overlap each other. The first student doesn't have any brown hair and doesn't wear glasses, so he's not going to enter any of the two sets, so we will keep him out. Next is a girl who has brown hair and she's not wearing glasses, so she has brown hair, so she will come in the set of brown hair. Okay, make her stand here. Next is a student who neither has brown hair nor he's wearing glasses, so he will not come in any of the two sets. We will make him stand outside of the two sets. Next is a girl who is wearing glasses. So she is a student who is wearing glasses. She should come in the set labeled glasses. So let's make her stand in the set. The next student has brown hair on his head and he's not wearing glasses. So he cannot come in the set labeled glasses, but he can come in the set labeled brown hair. So he will not come in the common part. He will come on the left portion of the brown hair set. Okay, next is a girl who does not have brown hair and she's not wearing glasses, so she is not going to come in any of the two sets. She will stay outside. Next is a student who is wearing glasses, but he does not have brown hair. He has black hair, so he will not come in the set of brown hair, but he can come in the set labeled glasses. So we will keep him stand on the right side of the set wearing labeled glasses. So on the right hand side, we will make him stand. We will not make him stand in the middle. All right. Next is a student who doesn't have brown hair and who is not wearing glasses, so he will come outside of the two sets. He will not come any of the two sets. Next is a student who has brown hair and he's wearing glasses, so he should come in the brown hair set and in the glasses set. So we will make him stand in such a position that he is in the brown hair set and as well as in the glasses set. So he will come in both of the sets. That is, he will come in the overlapping part. So he will come in the middle of the two sets so that he is in present in both of the sets. Next is a girl who has brown hair but she's not wearing glasses, so she will come in the set of brown hair people. So we have arranged all the students according to their fact that they have brown hair or not, or they are wearing glasses or not glasses. Next. So this is a very basic way of arranging items. Practically, it is very lengthy, cumbersome to arrange the pictures. It's better to count the values. We do not write all the ways, we actually count the values. So let us denote the event B that a student has a brown hair, and let us suppose that event G is the event that a student is wearing glasses. Sorting all the students, we are now going to count the number of students in various regions of this universal set. We have different regions here. For example, the set B itself has two regions. The three students on the left side and one student on the right hand side. and each region has a different concept, different meaning, different classification. We will discuss them all one by one. First of all, we will draw again the universal set, and this baby sign denotes the universal set. It's a Greek letter. The letter B will denote the students who have brown hair, and the letter G will denote the students who wear glasses. Okay, we are putting a 1 in the common region. Why? Because there is only one student who is wearing glasses and who has brown hair. So he is coming in the common part. This is called the intersection of the two sets. So the number of elements or the number of students or number of items common to both of B and G is only 1. Now 3 here. The number of students who have brown hair but they are not wearing glasses are 3. They do have brown hair but they are not wearing glasses. And the total number of brown students is, you can see, 3 plus 1. We will count that also. 2. Why 2 here? Because there are 2 students who are wearing glasses but do not have brown hair, right? They have different color hair, different from brown, but they are wearing glasses, so there are 2 in number, such students. And 4 students, they are not in any of the 2 sets. That means they neither have brown hair nor they are wearing glasses, so they are 4 in number. So total number of students, we can calculate the total number of students or total number of elements or items by adding all of the numbers in various regions. So 4 plus 3 plus 1 plus 2 will give us a total number of elements in the universal set, which is 10 here. Okay, then to count the number of elements in the set B, we have to count the various number of elements in various regions, 3 and 1. There are 2 different regions, but we will combine them, we will add them to get the number of elements in the set B. So total number of students is down here, 3 plus 1, that makes 4. This is the number of elements of set B. And number of students wearing glasses, 1 plus 2 is equal to 3. This 3 is the total number of elements of the set G. That means total number of students wearing glasses is 3. There are 2 types of students who are wearing glasses. 2 do not have brown hair, 1 has brown hair. So that's why they are in 2 different regions, but they all are wearing glasses. Now, the students who have brown hair and they are wearing glasses, there is only one such student which lies in the common part, which is standing in the common part of the 2 sets, overlapping part, which is called intersection, and this is only 1. And the number of students who neither have brown hair nor they are wearing glasses, they cannot come in any of the 2 sets, so they will stay outside. And there are 4 such students who neither have brown hair and nor they are wearing any glasses. And if we want to count the students who have either brown hair or glasses, that means uh, they have any one characteristic. Either they have brown hair or either they are wearing glasses. Only one is characteristic is good. So we will count all the students who have brown hair, who are wearing glasses, and who have both brown hair and wearing glasses. So 3 plus 1 plus 2 plus is equal to 6. These 6 students have either brown hair or they're wearing glasses. Let's discuss a question on Venn diagrams. There's a car park in which the total number of cars is 60, and there are blue cars. So all the blue cars will come in the set B, and there are sports cars S. And these numbers are given in the question 18, 2, 8, and 32. I will discuss them all one by one. 18, the number of blue cars is 18 plus 2, 20 are the total number of blue cars. And what does 18 represent? 18 represents the cars which are blue in color but which are not sports cars, they're ordinary cars. And what does 2 represent? 2 represents the cars which are blue and sports both, blue colored sports car. And what is 8? 8 is the number of sports cars which are not blue in color. They may have different colors, but they are sports cars. And the total number of sports cars here is 2 plus 8, 10. And then obviously there will be many cars which do not have blue color and which are not sports car, and they will not come in any of these 2 sets. There are 32 such cars which neither have blue color nor nor any of them is a sports car. Okay, so So we have to do four parts here, and we will find the probability of each part, each category. A part. In A part, we have to find the probability that the car is a blue sports car. When we say that a car is a blue sports car, that means it has a blue color and it is a sports car. That means it should come in both of the sets. So, how many cars are there in both of the sets? In the overlapping part or the intersection part, there are two cars. So, we will find the probability by dividing the favorable number of items by the total number of items. So, favorable number of items our outcomes is here is 2 and the total number of outcomes is 60, which is total number of cars. So we will divide 2 by 60 to get the probability of getting or selecting a blue sports car. And 2 and 60 will be simplified upon the by dividing upon the table of 2. In B part, we have to find the probability that the car is not a blue and it is a sports car. That means the car should be a sports car and its color should not be blue. How many sports cars are there which are not blue? You can see in the figure, they are in the yellow region. In the yellow region, we have 8. 8 are the cars which are sports, but they do not have blue color. So the probability will be 8 over total number of cars, which is 60. And we will simplify above and below by dividing by table of 2 again. We will divide by table of 2 and 2 over 15 is the answer in the simplest form. In C part, you have to find the probability that it is either a blue or a sports car. So first we should count how many cars are there who can we say are blue or sports. Any car which is either blue or sports will come into this count. So we will add up all the cars which are either blue or sports. The cars in the blue region are 18. The cars in the green region, which are both blue and yellow, they are 2. And the cars which are in the yellow region, they are 8 and which are sports and they don't have blue color. So all will come when we are saying that the car can be a blue car or a sports car. So 18 plus 2 plus 8 makes it 28. Now the probability of selecting such a car will be number of favorable outcomes, which is 28, divided by the total number of outcomes, which is 60. So the probability will be 28 of 60 and we simplify dividing above and below by 2. Answer will be 14 of 30. Again, we will divide above and below by 2. So answer will be 7 of 15, which is in the simplest form. So we now come to the fourth part of the question. Uh, we have to find a probability that if the car is neither blue or nor it's a sports car. So how many we have to count how many cars are there which are neither blue nor sports car. Neither their color should be blue nor should the car should be a sports car. So we can see such cars should be out of the two sets, which are how many in number? They are 32 in number. 32 cars are neither blue and they are nor they are sports cars. So we will divide 32 by the total number of cars to get the probability, and we will simplify above and below by dividing by 2. And again we will simplify. So 8 of 15 is the required answer. Example number 2. There are 30 students in a class and they're asked whether their favorite sports is cricket or football. Okay, so there are some of the results. Some of the word some is there. That means not all the counts have been written there. Not all the data has been entered there in the Venn diagram. There is a lot of data, but it's not all. It's not complete Venn diagram. So, and you can see if you add 12 plus 6 plus 8, it makes 26 students, whereas the total number of students is 30. That means some students are missing. So we have not recorded about some students, and we will see it later. So, this universal set is the students in the class. Set C is the students who like cricket, and set F represents the students who like football. Okay, first of all, we have to find the probability how many we have to find the number of students who like both sports. You can there will be students who are coming in both of the sets, who lie in both of the sets, who have been counted in both of the sets, who are in both of the sets C and F. So you can see such number of students what they should be in the green region, which is the overlapping or the common part region, a common region to both of the sets. So there are 6 students who like both of the cricket and football. In second part, we have to find how many students do not like either sport. Did the students who do not like either sport, right? This is not given in the Venn diagram, but we can find them. How? Because we know the total number of students, and from the total number of students, we subtract the number of students given in the various parts of C and F, we can get the number of students who do not like either of the two sports. Okay, so from 30 we will subtract 12, 6 and 8 to get the number of students who do not like cricket or football. These are foreign number and they are not out inside any set, they will stay outside of both of the set. So let us write this number 4 in the, add this number 4 to the Venn diagram. Here it should come out of the both of set C and F. Third part, write down the value of number n bracket C union F. This n means number of elements, right? And C union F means FC and F, the union of the set C and F. That means set C and F combined. So we have to write the number of elements in the set C and F combined. In both of the set C and F, what is the total number of elements we have to find? Okay, what are the total number of students who either like cricket or football? This we have to find here. That is the number of elements in C union F. Um, so we will add up all the numbers in various regions of C and F. 12 plus 6 plus 8. Uh, these are 26 in number. Remember that the 12 students are those students who like cricket only, they do not like football. And 8 students are students who like football only and they do not like cricket. And 6 students are the students who like both cricket and football. And the number of students who like cricket is not 12. They are 12 plus 6, 18. Okay, now let's move on to the fourth part. A student is chosen at random from the class. What is probably that this student likes football? Okay, what is probably that this student comes from the set F, who likes the students who like football. So for that we need to count the number of elements or the number of students which are in which who like football. That is the number of elements of the set F. And the set F has two regions, green and yellow. We will add both the number of elements in both of them. So the number of students who like football is 6 plus 8, and that gives us answer the 14. So now we can write the probability. How do we write the probability? Probability is equal to favorable number of outcomes divided by total number of outcomes. So probability that a student likes football is equal to the number of students who like football divided by total number of students. So number of students who like football is 14 and the total number of students is 30, and they both divide on 2, so we will divide them, and 715 is the required answer in the simplest form. Number 5, a student is chosen at random from the students who like cricket. Now he's saying that the student is chosen from the students who like cricket. Now there is no student in the class who likes football. They are all gone, might be for playing football. In the room or in the selection there are only cricket boys who play only cricket. Now what is the probability that, okay, the only those students have gone outside who like only football, and there are some students who like cricket also, they have not left the room, they are inside the room. So all the students who like cricket are inside the room. So what is probably that the student likes football? So a student chosen at random, what is probably that the student likes football? So out of these students, if we can choose a student who likes cricket only, or we can choose a student who likes cricket and football only. But we have to find a probability that the students likes football also. So number of students who like cricket is 12 plus 6, 18, and the number of students who like, out of these cricket students who like cricket, number of students who like football is 6. So the probability will be 6 over 18 now, because the total number of outcomes is 18. We are choosing out of the students who like cricket. Alright, so favorable outcomes is 6 and total outcomes is 18 here. And we will cancel upon the table of 6 and we'll get the answer 1 over 3. Let's now discuss another example on Venn diagrams and probability. There are 40 students in a class, out of which 15 study Spanish, 20 study French, and 12 study neither of these. So uh, there are some students who study neither of these languages, and 15 study Spanish and 20 study French. So what we have to do in this question, find the number of students who study both languages, that is N F intersection S. This N denotes number of elements and F intersection S means the common elements. So we have to find the students who study both of the languages, French and Spanish. And B part, then we have to fill the given Venn diagram, which is empty here. There are no elements put in any region. We have to fill this Venn diagram completely afterwards. Okay, then we'll do the rest of the parts. Okay, let's discuss the first part, A part first. Okay, first we have to find the common part, a number of elements in the common part of the two sets, number of elements in the intersection. The students who study French and Spanish both. Let us suppose that those students are X in number. In such questions, we always do start the question, the solution like this, that we suppose that the common number of elements, that is the elements in the intersection parts is X, and then since the number of elements, the total number of elements in the set S, the students who speak Spanish, who study Spanish is 15. So the number of students who speak only Spanish, that is the students who speak Spanish but not French, will be 15 minus X. X is the number of students who speak both of the languages, and the students who speak only Spanish, not French, that is the students in only blue region on the left region. So there will be 15 minus X because the whole of the students, the total count of the French students who speak Spanish is 15, out of which X speak both of the languages. So the students who study only one language, Spanish, is 15 minus X. Similarly, the number of students who study French is 20, out of which X study Spanish also. So the number of students who study only French, yeah, that is the students who study French but not Spanish, will be total 20. Total who study French, 20 minus the students who study both of the languages X. So it will be 20 minus X in the yellow region, and 12 students are the students who study neither of the two languages. They will come outside. That is very easy to understand. Now, since the total number of students is 40 here, these all numbers should add up to 40. So this way we'll make a mathematical equation which we can solve to find the value of X. So we will add all the numbers. We will add 15 minus X plus X, then 20 minus X and 12, and put the sum equal to 40. So let's write the sum. 15 minus X plus 20 minus X plus 12 is equal to 40. Now in this equation, negative X and plus X, they will cancel, and 15 plus 20 plus 12 will be 47. So we have written 47 in the beginning by adding 15, 20 and 12, and now we have negative X on the left, which when goes to right hand side will become positive, and we'll at the same time we'll take the 40 on the right to the left hand side so that we can find the value of X, and it will become negative when it comes to the left hand side. So it will be 47 minus X is equal to 40. When we have cancelled the X, now we will move 14 X. 40 will come to left hand side, its sign will change, and X will go to right hand side, it will become positive. 47 minus 40 will be 7. 7 is equal to X means the value of X is 7. So we have got the number of students who study both Spanish and French, and these are 7 such students. B part, we fill in the diagram completely. Now we will fill the diagram completely. Uh, uh, Till yet, the way we have filled the diagram, that is not a complete filling of the diagram because there is an unknown X. So we will put all of known values. We have found the value of X. We can find the exact number of students in every region. So first of all, we will replace X by 7 because we have found its value, that the total number of students in the common part, or the students studying both of the languages 7. So we will replace X by 7, and then the students who study only Spanish is 15 minus X. If we put the value of X there in 15 minus X, it will be 15 minus 7 equal to 8. So the students who study Spanish only are 8. So we will replace 15 minus X by 8, and then the students who study French only are 20 minus X. We will put the value of X there also. 20 minus X, we will replace X by 7. So 20 minus 7, 7 will be 13. So there are 30 students who study French only. So we will replace X as 20 minus X by 13. B part is done now. The remaining parts of this example 3 in C part, we have to, it's saying that a student is chosen at random, find probably that first the student studies both Spanish and French. So the probability that a student studies Spanish and French means first we should know the number of students who study both French and Spanish. They fall in the green region, which is the common or the intersection region, the overlapping part of the two sets. This is there are 7 such students, and the total number of students is 40. So we will divide the students who study both French and Spanish by the total number of students. So the probability will be 7 over 40, and it is the simplest form. In second part, we have to find the probability that a student either studies Spanish or French. Okay, so the number of students we will find the number of students who study either the Spanish language or the French language. We'll add the number of students in various regions who study only Spanish, who study both languages 7, and who study French only 13. All of these students are those who study at least one of the two languages, so we will add them all. So this number is 8 plus 7 plus 13, and they add up to 28. Now we can find the probability that a student selected at random studies either one of the two languages, Spanish or French, and the favorable number outcomes is 28 here. Total number of outcomes is 40, so we will divide the favorable by total number of outcomes to get the probability. Simplify by dividing by 2. Again, we will simplify. 7/7 is the required answer. In the third part, we have to find the probability that a student studies neither Spanish nor French. It doesn't study any of the two languages. So we can see in the Venn diagram there are 12 such students who do not study any of the two languages. So we will find the probability by dividing the number of students who do not study any of the two languages by the total number of students, and it will be what? It will be simply 12 over 40, and we'll simplify the answer. Again, we'll simplify, and this is the required answer.